Yeah. So, hi guys. Welcome to lesson 7 of geography series. Today we are going to discuss about geomorphic processes. So, uh, what is geomorphic process? Geo means earth, morphic means physical change. Okay, geo means earth, morphic means physical change. Uh, Thus, the processes or the forces which bring about physical changes on the surface of the earth are called as geomorphic processes. Okay, again, the forces or processes which bring about physical changes on the surface of the earth are called as geomorphic processes. Okay, these geomorphic processes are of two types: endogenetic, exogenetic. Okay, uh, endogenetic are those forces which operate inside of the earth. They operate inside of the earth. For example, our convection currents that happen inside of the earth, they are endogenetic forces which are responsible for the movement of the lithosphere. Okay, so these endogenetic forces are responsible for building up Okay, and endogenetic forces are the forces that operate inside of the earth. First thing, second thing, these forces help in building up of new crust. So, building up of continents happen through endogenetic process. Okay, and yes, the forces responsible for endogenetic process are convection currents inside the earth. Okay, and secondly, exogenetic. These operate outside of the earth. Okay, um, and these exogenetic forces are responsible for transportation, weathering, transportation, and deposition. So, like in through endogenetic forces, we can see building up of continents or crustal plates. Okay, so and the relief features on those continents, like uh, the mountains. Now you see, like, okay, mountains are formed due to endogenetic force only. I'm not talking about the actual raw format of the mountain, the features that you see on them. Okay, uh, if if through endogenetic process, if a mountain formed is very steep, through exogenetic process, it may become gentle also. So, okay, the physical features that are responsible, that we see today, are due to the effect of exogenetic forces. Okay, what does this exogenetic forces do? These exogenetic forces transport the material. For example, they denude a mountain. Okay, transport that material. Okay, and deposit that material somewhere else. Okay, so that features are formed on the earth. For example, the water weathers means ruptures the Himalayan mountains, transports the deposits of the mountains, and settles down them in the Indo-Gangetic plain. Okay, the that is exogenetic forces. Endogenetic forces are responsible for building up, and exogenetic forces are responsible for, gradation. We say it gradation, degradation of features. Okay, yeah, we said gradation, right? Exogenetic forces are responsible for this. Okay, for gradation. So what is gradation? Gradation means nothing but weathering or denuding. Okay, in common terms we say uh, I don't say destruction. In common terms we can say it as rupture. Okay, in common terms gradation means nothing but rupture of a feature. Okay, of a physical feature. Yeah, and this through this gradation, we can see two types of process: degradation, aggradation. So what happens in a degradation? In degradation, uh, water, wind, or any other natural element can denude a mountain. That is, takes away its feature or deposits or material. Okay, in degradation, what happens? A natural element like wind or water can take away the materials of a physical feature like mountains. Okay, in aggradation, there is filling up. That is deposition of materials into a depression. It is called as aggradation, filling up of materials in like uh, filling up of deposits. Deposition is called as aggradation. So we have seen exogenetic and endogenetic forces. Okay. Next, next there is a term called geomorphic agent. What is geomorphic agent? A natural element like wind or water or glaciers, which can transport a material from one place to another place is called as a geomorphic agent. So a natural element like wind, water, glaciers, etc. These can transport materials from one place to another place. That is, from the place of weathering to the place of deposition. These geomorphic agents transport the materials. Okay, that is geomorphic agent. And so for exogenetic forces to operate, we need geomorphic agents, and also it I don't say thing. Apart from geomorphic agents, we need another force called as gradient. Okay, gradient means nothing but difference. Okay, how does a force develop? See, for a geomorphic agent to take away the material, first of all, the material has to move, right? What is responsible for the movement of that material? It is the gradient that is responsible for the movement of that material on earth. That gradient is developed by gravitational force. Because of this gravitational force only, materials move from high concentration to low concentration, from high pressure to low pressure. Okay. So whenever a material moves from high concentration to low concentration because of the gradient or the difference, gradient is nothing but difference in what? Gravitational force. Okay, the higher concentration material will have like, you know, higher concentration material uh, will be on top of a mountain, and due to gravitational attraction of the earth, that material falls down and goes from higher concentration area to lower concentration areas. Okay, whenever the material starts moving, these geomorphic agents transport that material from one area to another area. Okay, so a gradient is important for materials to start mobilizing, start moving. Okay, that gradient force is developed on the earth by gravitational, I mean that gradient on earth is developed by gravitational force. Okay, yeah. Next one. So this is introduction for geomorphic process. Two types of process are there: endogenetic and exogenetic. Now we will see in detail what is endogenetic and exogenetic. Endogenetic. These endogenetic forces are of two types: diastrophism and sudden movement or sudden forces. And again, diastrophism is divided into two types: epiorogeny and orogeny. Okay, and again, epiorogeny is divided into upward movement, downward movement, and orogeny is divided into bending, that is crustal bending, crustal fault, bending or folding, crustal fault. Sudden forces are of two types: volcanism and earthquakes. So, endogenetic forces, the forces that operate within interior of the earth, are divided into two types. Okay, one is diastrophism and another is sudden forces. Okay, due to diastrophism and the sudden forces, different features are formed on earth. Okay, for example, if you take sudden forces, volcanism and earthquakes, we have already dealt that. Due to volcanism, we can see different volcanoes that are formed under that shield volcanoes, you know, cinder cones, composite volcanoes and all. Similarly, due to earthquake also different features are found, but they are not that much pronounced on earth. Pronounced in the sense, they are not, very significant features. They are not very significant features, very minute features. And moreover, this earthquake is, mostly associated with destruction rather than a construction thing. Because of that destruction, some features may be formed. Okay, due to that earthquake, like suddenly, we can say due to these earthquakes, two land masses can divide like this, and a gap is formed in between them, and gradually that gap can be filled with water. Okay, but due to earthquakes we cannot see, these kind of features formed in larger area. Only smaller area only these kind of features are formed due to earthquakes, and volcanoes also. Due to volcanoes also, the features are found on a smaller area rather than a large area. Okay, that is due to sudden forces. Okay, these kind of features are built like volcanoes, and small features that are built due to earthquake. But when it comes to diastrophism, due to diastrophism we can see two kinds of formations on earth. The first one is epiorogeny. This means, epiros means continent, and genesis, that is origin. So epiorogeny is associated with building up of continents. Okay, epiorogeny is associated with building up of continents, and moreover, it is a vertical movement. And we there is no such thing called appearance of folds or faults. They don't appear. There is no such thing as appearance of folds or faults during epiorogeny, because epiorogeny is a continent building process and it is a vertical movement. Okay, why vertical we say? See, the initial earth, as we dealt in previous lessons, the initial earth consists of crust, mantle and core. Due to the convection currents happening in mantle, you know, uh, let's say this is the crust and this is magma. The magma came out, settled on the surface of the earth, solidified into continents. So it is a vertical movement. Okay, this is a vertical movement. So there is upward movement and a downward movement also. Okay. Moreover, these continental parts are sometimes submerged under the ocean also. So diastrophism consists of upward movement and downward movement. Okay, and it results in the building up of continents. And it is a vertical movement. It is not a horizontal movement. Continent building is a vertical movement, and it happens over a large surface area. Okay, larger area, right? Due to the upwelling of the magma vertically onto the surface of the earth, this magma on over a period of time got solidified and formed into continents. Thereafter these continents drifted. Okay, initially how the continent mass is formed, that is a continent, we have learned that Pangea, how that Pangea unit of mass has formed, because it is due to vertical movement of the magma and solidification of the magma, a continent is formed. And after that, due to movement of the plates, these continents got divided, and that's what we are seeing today. So continent building, it's a vertical movement, and there are no faults or folds or faults. Okay, there is no folding of crustal plates or breaking of the crustal plate. It is just that uh, the crust comes up and solidifies. I'm said sorry, magma comes up and solidifies. Okay, and it is up. This epiorogeny consists of upward movement and a downward movement also. Upward movement is rising of magma and solidifying as continents. Downward movements is sometimes these continental features get submerged under the ocean. Okay, and it is a downward movement. This is how continents are formed. We often see that you have come across a place called Run of Kutch in Gujarat, western part of India. It is sometimes submerged under the ocean. Sometimes it appears on the surface. Okay, so we can say that this continental masses are upward movement and a downward movement. Upward movement means emergence. Downward movement means submergence. Okay, and next we go to orogeny. Orogeny is important. Orogeny means, oros means mountains. Genesis means, yeah, as we said, origin. So orogeny deals about formation of mountains. Okay, so orogeny deals with the formation of mountains. Yeah, on Earth we can see two types of mountains: fold mountains, block mountains. Okay, how these fold mountains are formed? Wait. Yeah. See, sorry. Fold mountains. Okay. We have said that, see, yeah, orogeny results in, I mean, orogeny can be, can happen through two types of movements, that is crustal bending or crustal faulting. Okay. This is crustal bending. This is your crust portion. Okay. And due to compression, that is convergence, this crust got, wait, this crust got bent. Okay. This is bending. Due to compressions, the crust got bent, bent and formed a series of folds. Okay. In this series of folds, this downward fold is called as syncline. Oh yeah. And upward fold is called as anticline. Okay. Due to compressional forces, that is due to converging forces, the crustal part got bent or folded. Okay. And due to folding, this a series of wave kind of structure is appeared. For that, the downward fold is called as syncline and upward fold is called as anticline. Okay. Yeah. So and here the crust is shortened. Okay. There is shortening of the crust for, during a convergence or a compressional movement, right? Yeah. So due to this folding, a series of folded mountains are formed on different parts of the continent, I mean earth. Okay. We will look into it, what are those important fold mountains are. But initially, there is another concept called as geosyncline. Geosyncline. Okay. See, geosynclines are nothing but long, narrow belt. They are long and narrow that are, and they have two continental masses on their either side. Okay. They are narrow. Width is very narrow. Okay. And they are long. I mean, long like this, and width width is very small. They are narrow, but they are lengthy in nature. Okay. um, these are nothing but depressions between two continental masses. These depressions are filled with water, and also not only water. From these continental blocks, we can see sediments pouring down. Okay. Sediments, right? Sediments pouring down. And due to gradual sedimentation, this belt right here will subside down, it goes down. Okay. And again gets filled with sediments. Again, due to heavy sedimentation, again it subsides down and again gets filled up with the sediments. Sediments come from where? From the continental blocks. Okay. So thus between two continental blocks, there is a long narrow belt called as geosyncline. Okay. This geosyncline is characterized by gradual sedimentation and submergence. Okay. Due to over long period of time, due to this gradual sedimentation and submergence, these geosynclines will appear like this. Not exactly in that rectangular way, but they appear, like similar height with the uh, continental masses. Once they appear like that, compressional forces compress those sediments. These sediments gets after after gradual sedimentation and submergence, you know compressional forces compress these two continental blocks. When these two continental blocks get compressed, these sediments rise above and form as folds, and due to gradual compression and compression for over very long period of time, these folds will appear as fold mountains, right? If this is a continent and this is a continent, due to gradual compression over a longer period of time, these sediments gets folded and appear as series of folded mountains, right? Okay. If the compression is very happens in a for a very longer period of time, there will be a series of folded mountains. Okay. If the compression is not that much strong or not that much aggressive, it will form something like this with fold mountains and a highland area and again fold mountains. If the compressional forces are not that much strong or not that much aggressive, we can see something like this with folded mountains on either sides with a landmass between them. And if the compressional forces are stronger, those sediments gets folded and appear as folded mountains like this, continuous folded mountains. So for these folded mountains, the best examples would be Rockies in North America, Andes in South America, Alps in Switzerland, Atlas mountain ranges in North Africa, Morocco region, our very own Himalayas. These are the important fold mountains on the continent in the on Earth, which are formed due to compression of the sediments present in the geosyncline. Okay, due to gradual compression, those sediments gets folded into folded like this and formed a series of mountains, right? If the compression is very strong, they form a series of mountains. If the compression is not that much strong, they will form a series of folded mountains with a land mass between them. And example for this is Tibetan Plateau and Bolivian Plateau. How Tibetan Plateau will be there? We can see series of folded mountains called as Himalayas, and in between them there is a plateau called Tibetan Plateau, and again another series of folded mountains called as Convention. Okay, if you take India like this, okay, from here there will be Himalayas, and here there is Tibetan Plateau, and again here there is Convention. Okay, and also Bolivian Plateau. In between Andes mountains, there is a gap or a landmass called as Bolivian Plateau in South America. Okay, this is about fold mountains. Okay, how geosynclines formed, how the sedimentation happened, how these sedimentations emerged into or evolved into folded mountains. We have seen just now, and it is due to crustal bending by compressional forces, that is converging. Okay, and I have said that there is crustal bending or folding like this. Okay, uh, see, due to continuous compression, we can see formation of anticline, the upper fold, and syncline called as the lower fold. Okay, if the compressional forces are very after the still after the formation of anticlines and synclines, if the compressional forces still they act on that sedimentation, we can see asymmetrical fold. Asymmetrical fold is nothing but if the upper wave is length is like this, and the lower wave length will be like this. It is asymmetrical in nature, not symmetrical. If you see this, this is symmetrical. Length is same everywhere, but here length is not same. Asymmetrical fold. Further compression results in overfold. Okay, and further compression results in recumbent fold. And the extreme form of compression leads to napping. Napping is nothing but due to gradual compression, um, we cannot see gap between the folds. The gap gets reduced from simple fold to nappy. We can see the gap gets reduced, and it will appear something like this. It is called as nappy. Okay, that's why the best example for this nappy kind of folds is Swiss Alp mountains. Okay, there is no such much gap between those folds. They are continuously formed like this. Okay, there is no much gap. Due to gradual compression, the gap between these folds gets reduced from simple fold to nappy. The final stage is called as nappy, wherein the folds will be parallel to the plane. Okay, yeah. And next we'll see block mountains. We have already dealt block mountains in detail while I'm covering about divergence. Please do check about it. Okay, block mountains. What happens in a block mountain? See, while we are studying about, while we are studying divergence boundaries, we said that due to divergence, uh, block mountains are formed. Okay, block mountains can also be formed through convergence also. Okay, how we will see now. See, it, it is a continental block. Okay, this is a continental crustal crust. There are forces, compressional forces like converging forces acting on this. Due to these converging forces, faults appear. Can you see those red lines? I think it's not that much visible. Yeah. Due to compression, faults appeared in the crustal part. Okay. And in the second stage, what has happened? Due to much convergence, due to uh, gradual convergence, uh, the block beside that fault got subsided down. Okay, here also we can see subsidence and subsidence, and the result, the upward block in between two subsided regions is called as a block mountain, which is formed due to convergence. This kind of block mountains are formed due to convergence, that is crustal faulting. Due to gradual convergence, crustal faulting has happened. Due to this crustal faulting, we can see subsidence, and the block that is present in between two subsided blocks is called a block mountain, that is formed by convergence, and the subsided parts are called as rift valleys. And sorry sorry, I'm really sorry. Due to divergence, this is due to divergence, faults has appeared in the crustal part, and faults appeared in the crustal part, Okay, due to divergence, faults appeared in the crustal part, and at those and after that, due to further divergence, those the place where fault has developed, the block subsided down, and the block present between two subsided blocks is called as block mountain, that is formed by divergence forces. And block mountains can also be formed due to convergence. See, due to convergence, there is crustal faulting appeared here, and this fault gets subsided down, and the blocks present on either side of a subsided part are called as block mountains. Okay, um, a rift valley with two block mountains on either side is formed due to compressional forces, and a block mountain with two subsided or two rift valleys beside it is formed due to divergence. Okay, this is how fold mountains and block mountains are formed. Yeah, so yeah, that's all for today. We have seen orogeny and yeah, we have seen epiorogeny and orogeny. Due to epiorogeny, there is a continent building. There will be upward movement of the continent and downward movement of the continent. Upward movement is called as emergence. Downward movement is called as submergence. Due to orogeny, there is crustal bending or folding. Crustal bending or folding results in the formation of anticlines and synclines, uh, uh, and results in the formation of fold mountains. And material or for that fold mountains is formed through sedimentation that happened in geosynclines. Geosynclines are formed, sedimentation is formed. After the sedimentation, compression took place, and due to that compression, a series of fold mountains are formed. If the compression is very strong, we can say series of folded mountains. If compression force is nominal or medium, we can say series of fold mountains with a landmass between them. And after that, crustal fault. It crustal fault means breakdown of the crustal part. Due to that breakdown of the crustal part, we can see formation of block mountains. Okay, this crustal faulting can also happen due to compression or divergence. Divergence is also called as tensional force. Okay, but crustal folding or bending can happen only due to compression. Okay, and moreover, orogeny is a horizontal movement. Apiorogeny is vertical. Right, and for folding, we have seen formation of for a simple fold, of after that asymmetrical fold, and after that overfold, recumbent fold, and nappies. Similarly, for fault also there is normal fault and a reverse fault. Okay, the basic difference between normal fault and reverse fault is that I have said that the block subsides down, right? Okay, if the block subsides along the plane, subsides down, that is it is acting towards the gravity acts downwards, right? It acts towards the gravity, so we can say it is a normal fault. The block is moving down along the gravity, so it is normal fault. What happens in a reverse fault? The block moves upwards, that is moving against the gravity. It is a reverse fault. That's all. So, in next class, we will see about exogentic forces, that is your weathering, mass movement, and all, and formation of soil. Yeah, thank you.